This is OpenNMS 101 again, Module 11, Part A, Data Collection Overview. This video focuses on how OpenNMS is configured to collect performance data using SNMP. The documentation is in the Horizon Operations documentation under Deep Dive Performance Management. Collection is configured in the file called collectd-configuration.xml. This file defines which collections are being collected and assigned to which nodes. Horizon ships with over a dozen collectors, including HTTP, JDBC, JMX, and SNMP. The reference documentation is in the Horizon Reference documentation under Collectors. Collectors make use of one or more configuration files. This is a list of Horizon collector configuration files. This video focuses on SNMP. The SNMP collector configuration files are snmp-config.xml, which defines a per-host security setting for SNMP communication, datacollection-config.xml, which defines data collections via SNMP. Configuration is reprocessed when the file is modified. XML files in the data collection directory define data collections via SNMP. Files in this folder must be specified as an include directive in the datacollection-config.xml file. As was discussed in Module 6, SNMP access on the local host is restricted to SNMP v3. The authentication and privacy parameters are stored in snmp-config.xml. This file has to be configured correctly for each device Horizon will extract SNMP parameters from. Begin at the local host front page. There are some bits of data to note. The node ID is 1. The sysoid is .1.3.6.1.4.1.8072.3.2.10. And there are two sets of interfaces, 127.0.0.1 and 192.168.159.105. Collected data can be viewed by clicking on Resource Graphs. Select Node Level Data by checking on the box labeled Node Level Performance Data and clicking on Graph Selection. A number of graphs will appear. The easiest one to analyze will be the Current TCP Connections. Mark down that title. Return to the Resource Graphs page. Select SNMP interface data by checking the box labeled ENS 160 and clicking on Graph Selection. Again, a number of graphs will be presented. Select the Bits In Out High Speed. Mark down this title. Return to the Resource Graphs page. Scroll down a bit to the Storage SNMP MIB2 Host Resources and check the box next to the single slash. Click on Graph Selection. A single graph appears. Storage Utilization on /. Mark down this title. Change to the /op/openNMS/etsy/snmp-graph.properties.d directory. This directory contains the OpenNMS graph definitions. Use the graph titles to determine the metric constituents of each graph. Search for Current TCP Connection. That graph is defined in mib2-graph.properties. Search for bits in/out high speed. That graph is defined in mib2-graph.properties. Finally, search for storage utilization on. That graph is defined in mib2-graph.properties. Edit mib2-graph.properties. Search for current TCP connection. This graph makes use of TCP cur estab metric. Search for bits in/out high speed. That graph makes use of the IFHC in octets and IFHC out octets metrics. Search for storage utilization on. That graph makes use of the HR storage size, HR storage used, and HR storage alloc units metrics. How does OpenNMS know to collect these metrics from localhost? Begin by progressing through the collector configuration files by starting in the data collection directory. Search through each XML file in the data collection directory for the metrics just discovered. Note the group name that contains each metric. Find a sysdef with a sysoid or sysoid mask that matches the sysoid of localhost and contains the group name containing the metric. Use the data group name of the file containing that sysdef. Change to the data collection directory and look for all the metrics using the egrep as shown. All the metrics are defined in the mib2.xml file. Edit mib2.xml. The data collection group name is mib2. Search for TCP cur estab. It is in the mib2-tcp group. Search for mib2-tcp in the file. Fortunately, it is in a sysdef labeled Enterprise. The sysoid mask .1.3.6.1.4.1 matches the sysoid of localhost. The data collection group name is mib2 for this metric. Search for ifhc in octets. It is in the mib2-x-interfaces group. This group also contains ifhc out octets. Search for mib2-x-interfaces in the file. It is in the same sysdef labeled Enterprise. The sysoid mask .1.3.6.1.4.1 matches the sysoid of localhost. The data collection group name is mib2 for this metric. Search for HR storage size. It is in the mib2-host-resources-storage group. It also contains HR storage used and HR storage units alloc. Search for mib2-host-resources-storage in the file. This group is not found in a sysdef in this file. Return to the command prompt and search all files in the data collection directory for mib2-host-resources-storage. There will be a lot of matches. Recalling that SNMP was installed on the local host using the netsnmp package, the first place to check is the netsnmp.xml file. Edit netsnmp.xml. The data collection group name is net-snmp. Search for mib2-host-resources-storage in the file. The first matches sysoid mask does not match localhost's sysoid. The second match with sysdef equal to net-snmp has a matching sysoid mask. The data collection group name is net-snmp for this metric. Close the file. The data collection group mib2 will collect TCP cur estab and ifhc in/out octets. The data collection group net-snmp will collect HR storage size, HR storage used, and HR storage alloc units. These data collection groups need to be included in datacollection-config.xml. Change directory to /op/OpenNMS/etc and edit datacollection-config.xml. Search for mib2 and net-snmp. Both groups are included in the SNMP collection named default. The final collector configuration file is collectd-configuration.xml. Change directory to /op/OpenNMS/etc. Edit collectd-configuration.xml. Search for SNMP. Note that the parameter collection is default. This verifies that the SNMP collection named default in datacollection-config.xml will be used. Search further and note that the collectd.snmp collector class is attached to this service. In OpenNMS, the purpose of files in the data collection subdirectory is to organize objects into groups, groups into sysdefs, and sysdefs into data groups with names at the top of each file. Sysdefs are applied to individual elements using a sysoid, or a class of elements using a sysoid mask. The purpose of data collection-config.xml is to collect the data groups into an SNMP collection with a name. The purpose of collectd-configuration.xml is to attach a service to an SNMP collection using the SNMP collection name found in data collection-config.xml. For this tutorial, create a file, data collection/tutorial.xml. Use data collection/mib2.xml as a model. The first item is the data group name. Use the name tutorial. Note the uppercase T. Continuing with mib2.xml as a model, the group name will be tutorial. The tutorial's monitored element will not be related to interfaces, so set the IF type to ignore. The MIB object data has yet to be determined. Leave it as a comment for the moment. The system dev is given the name tutorial. The sysoid is set to the sysoid of the Linux box. The group to include is tutorial. This is what the data collection/tutorial.xml looks like for the moment. As noted, the MIB object line needs to be worked out. Add an SNMP collection element to datacollection-config.xml. Give it the name tutorial. This name will be used in collectd-configuration.xml. For the moment, and this will change, the RRD element is a copy and paste from the default SNMP collection in the same file. This will be modified. Note that this element is commented out in the data collection-config.xml file for the present. Finally, add a package named tutorial to collectd-configuration.xml. Use the standard filter and include range elements for the moment. The service name is SNMP. The collection value is tutorial, as this is the SNMP collection name in data collection-config.xml. Note that this element is commented out in the collectd-configuration.xml file for the present. There are a few things to do before Horizon is configured to collect tutorial data. 1. Find a tutorial data source that will be used to complete the MIB object element in data collection/tutorial.xml and configure RRD in the tutorial data collection group.